Imagine a time when the Earth's continents weren't scattered across the globe as we know them today. Instead, they were all connected, forming a single, vast supercontinent. This was Pangea, a world where the landmasses were fused together in a way that seems almost unimaginable now. But how did this supercontinent form? And more intriguingly, how did it break apart? What did the existence of Pangea mean for the development of life on Earth? These questions are not just about ancient geography. They challenge our understanding of the planet's dynamic nature and the forces that shape our world. Pangea existed roughly 335 to 175 million years ago, a time long before humans and even dinosaurs walked the Earth. During this era, the continents we know today, North America, South America, Africa, Europe, Asia, and the others, were all part of one massive landmass. The Earth's crust is constantly in motion, driven by the forces of plate tectonics. Over millions of years, the tectonic plates which form the Earth's outer shell moved and collided, causing landmasses to drift together. This slow but unstoppable movement led to the creation of Pangea. Imagine the continents as pieces of a gigantic puzzle, slowly coming together to form one unified whole. But this was not a permanent arrangement. Just as Pangea was formed by the shifting of these plates, it was eventually broken apart by the same forces, leading to the fragmented continents we see today. The existence and eventual breakup of Pangea raise profound questions about the Earth's changing nature. The separation of such a massive landmass didn't happen overnight. It took millions of years, reshaping the planet's surface and creating new oceans, mountains, and climates. As Pangea broke apart, the newly formed continents were subjected to entirely different environmental conditions. The climate of the Earth shifted, ecosystems changed, and species were forced to adapt to these new, often harsher conditions. The breakup of Pangea wasn't just a geological event, it set the stage for the evolution of life. The separation of the landmasses created isolated environments, allowing species to evolve in different ways. It's a reminder that the Earth's surface is never static. It's a constantly shifting, fluid entity. The breakup of Pangea forces us to think about the fragility of our world. Could something similar happen again? Could the continents drift back together in the future? While the land itself was changing, the surrounding oceans played an equally important role in shaping life on Earth. These vast bodies of water were not just geographical barriers, they were crucial to the evolution of species and ecosystems. Let's now turn our attention to the oceans that surrounded Pangea and how they influenced the planet's history. Before the oceans we recognize today carved out the familiar coastlines of Earth, there existed Panthalassa, a vast global ocean that surrounded the supercontinent Pangea. This was a time when the sea was not fragmented into the familiar Atlantic, Pacific, and Indian Oceans, but rather formed a single, uninterrupted body of water. What was life like in this immense ocean, and how did it play a role in shaping the planet's continents? Panthalassa wasn't just a geographical feature. It influenced everything from climate patterns to the evolution of life on Earth. Panthalassa was an ocean unlike any we experience now. Stretching from the polar regions all the way to the equator, it encircled the massive landmass of Pangea. The sheer size of Panthalassa made it a defining feature of Earth during the time of Pangea. Unlike the relatively shallow seas that dominate Earth's surface today, Panthalassa was deep and expansive. Its waters were affected by currents that would have been vastly different from today's, driven by the movement of the supercontinent and the position of the landmasses. These currents would have influenced the climate, weather patterns, and ocean temperatures, creating a much warmer and more humid world. Panthalassa's enormous size had a profound effect on the climate of Pangea. Its presence kept much of the Earth's weather regulated, contributing to a more stable, albeit tropical climate across the supercontinent. The existence of Panthalassa played a crucial role in the evolution of life. By acting as a barrier between different regions of Pangea, it isolated the landmasses, creating a natural division between the creatures that lived on each. As Pangea began to break apart, this isolation became even more pronounced. Species that were once part of a continuous ecosystem were now separated by vast expanses of water. Over millions of years, this isolation forced life to evolve in different ways on each new landmass, giving rise to distinct species and ecosystems. This process of isolation and adaptation is a fundamental driver of the diversity of life we see today. But what if Panthalassa hadn't existed? What if the landmasses had been connected by land rather than water? Would evolution have taken the same path? Or would species have intermingled, resulting in a very different world? The vast ocean surrounding Pangea was instrumental in shaping life, but it wasn't just the oceans that defined this ancient world. The skies above were just as crucial, with a drastically different atmosphere influencing everything from the weather to the survival of early species. Let's dive into the atmosphere of Pangea in our next segment and explore how it set the stage for life on Earth. Imagine the air that surrounded Pangea, vastly different from the atmosphere we breathe today. What were the environmental conditions that allowed life to flourish or struggle in such a radically altered atmosphere? How did the thick, carbon-rich air affect the evolution of life on Earth? And how did it contribute to the planet's climate? The atmosphere of Pangea was much thicker than the one we experience now. It contained significantly higher levels of carbon dioxide, which created a much stronger greenhouse effect, trapping heat within the atmosphere. This warming effect was crucial for life, as it maintained a stable, temperate climate, even in areas that are currently much colder. However, this warmth came with its own challenges. Because Pangea was one enormous landmass surrounded by the vast ocean of Panthalassa, the ocean currents would have been very different from those we see today. The lack of smaller landmasses meant there were fewer barriers to the movement of air, which would have led to temperature extremes. Areas near the equator could have been intensely hot, while parts of the supercontinent closer to the poles would have been uninhabitable. The humid atmosphere would have created lush tropical forests in some regions, while others, particularly those far from the ocean, may have experienced extreme deserts. This diversity in climate would have impacted not just the landscapes, but also the life forms that evolved in them. With fewer natural barriers like mountain ranges, weather systems would have been less predictable, and storms would have been more intense. The atmosphere would have constantly shaped the conditions in which life lived and evolved, making it a powerful force in the development of Earth's ecosystems. The unique atmospheric conditions of Pangea undoubtedly had a profound impact on the evolution of early life. Plants and animals that thrived in this environment had to adapt to extremes. How did life survive the scorching deserts and yet manage to flourish in humid, tropical regions? Could the higher oxygen levels have contributed to the gigantism of early life forms, such as the large trees and towering dinosaurs? The atmospheric conditions of Pangea may have played a key role in sparking biological innovations that paved the way for the extraordinary diversity of life we see today. It's fascinating to think about how such an environment, so different from what we experience now, could have shaped the early forms of life that emerged. As we consider the atmosphere that shaped life on Pangea, we must also turn our attention to the creatures that called this supercontinent home. How did they adapt to such extreme conditions, and what impact did these adaptations have on the evolution of life? Let's explore the age of giant creatures next. When we think of Pangea, the images of colossal creatures like dinosaurs often come to mind. But what was the connection between the size of these creatures and the environment in which they lived? How did the conditions of the supercontinent shape the extraordinary size of life forms that roamed its vast landscape? Pangea was home to some of the largest creatures ever to walk the Earth, including towering dinosaurs and massive prehistoric plants. The atmosphere during this time was thick with oxygen and carbon dioxide, which would have been crucial in supporting such giant life forms. The higher levels of oxygen in particular would have played a key role in the gigantism of these animals. The oxygen-rich environment allowed for more efficient respiration, enabling larger animals to sustain their massive sizes. The climate of Pangea, warm and humid, also supported an abundance of plant life. This lush, tropical vegetation served as the primary food source for herbivores, which in turn fed the carnivores, creating an interconnected ecosystem where large animals could thrive. The supercontinent's unbroken landmass also played a role in supporting these giants. With no significant geographical barriers to break up the ecosystems, animals had access to continuous stretches of land rich in resources. This abundance of space and food allowed animals to grow to unprecedented sizes, as they could roam and forage without the limitations imposed by fragmented landmasses. Additionally, the lack of substantial mountain ranges and natural barriers meant that weather patterns were more predictable, contributing to the stability of the ecosystems. The sheer size of these creatures challenges our understanding of biological evolution and the physical limits of life. Could life evolve to such monumental sizes again? What role did the environment, particularly the oxygen-rich atmosphere, abundant food supply, and warm climate, play in shaping these massive creatures? The gigantism of animals on Pangea raises profound questions about the influence of the environment on evolution. In today's more fragmented world, with colder climates and less dense atmospheres, could life ever reach such monumental sizes again? The giants of Pangea serve as a reminder of the remarkable ways in which life adapts to its environment, pushing the boundaries of what we think is biologically possible. While the giants of Pangea roamed the land, there were invisible forces beneath the surface shaping their world. Let's explore the geological forces at play under Pangea's surface, and how these forces contributed to the shaping of life on the supercontinent. Beneath the vast expanse of Pangea's landmass, immense forces were at work, constantly reshaping the Earth. The movement of tectonic plates, the massive slabs of Earth's crust, played a fundamental role in the formation and eventual breakup of Pangea. But how did these tectonic movements shape the planet's surface, and what impact did they have on the life that existed on it? Pangea came into existence due to the slow but powerful collisions of tectonic plates, which brought together the land masses that we now recognize as separate continents. Over millions of years, these plates shifted and collided, forcing one plate to dive beneath another, creating mountain ranges, volcanic activity, and earthquakes. The dramatic forces at play were not only responsible for the formation of Pangea, but also for the very shape of the Earth's surface. These tectonic collisions generated volcanic activity that poured vast amounts of gases, including carbon dioxide, into the atmosphere, contributing to the greenhouse effect and keeping the Earth warm. As Pangea began to break apart, these same tectonic forces continued to shape the planet, pushing the separated landmasses apart and creating new ocean basins. This process, called continental drift, was responsible for the rearrangement of the Earth's continents over geological time. As the supercontinent fractured, new oceans like the Atlantic formed, while existing mountain ranges were further sculpted or raised to greater heights. The dynamic nature of Earth's crust raises fascinating questions about the future of our planet. How will the continents continue to drift? Will they eventually come back together to form another supercontinent, as scientists predict with the concept of Pangea, or will they drift further apart? The constant motion of tectonic plates, though imperceptible on a human timescale, constantly reshapes the Earth's surface in ways that are beyond our control. In fact, tectonic forces remind us just how little we influence the planet's geological evolution. We live on a constantly changing Earth, where the land beneath us is always shifting, albeit at a pace that seems too slow to notice in our lifetime. Understanding tectonic activity not only gives us insight into the Earth's past, but also hints at how our world will continue to change over the next 100 million years. Pangea's breakup didn't only alter the planet's geography, it also had profound effects on the life that inhabited it. The changing landmasses and climates set the stage for massive extinction events that would shape life as we know it. Let's explore how these cataclysmic events changed the course of biological history. Pangea's existence was not without its cataclysmic events. Throughout the history of the supercontinent, massive extinction events reshaped the course of life on Earth. These mass extinctions were often triggered by extreme environmental changes, such as volcanic eruptions, asteroid impacts, and shifts in climate. But how did these devastating events impact the evolution of life? And what lessons can we learn from them? The most notorious extinction event during Pangea's era was the Permian-Triassic extinction, which occurred about 252 million years ago. This event is often referred to as the Great Dying, due to the catastrophic loss of life it caused. Over 90% of Earth's species were wiped out. The causes of this mass extinction are still debated by scientists, but it is believed that a combination of massive volcanic eruptions, which released vast amounts of carbon dioxide and methane into the atmosphere, and a significant shift in the Earth's climate and sea levels played a key role. The warming of the planet, along with ocean acidification and loss of oxygen in the seas, created a hostile environment for many life forms. This catastrophic loss of biodiversity created vast ecological gaps, allowing new species to evolve and fill the empty niches left behind by those that perished. The Permian-Triassic extinction was not the only mass extinction event during the time of Pangea. There were several others, each one contributing to the ever-changing landscape of life on Earth. These events were a result of the volatile environment created by the shifting tectonic plates, changes in the atmosphere, and the ongoing process of continental drift. The dramatic fluctuations in the Earth's climate and ecosystems constantly reset the course of evolution, forcing life to adapt in order to survive. Mass extinctions force us to reconsider our understanding of evolution as a linear progression. Are we truly advancing, or are we merely adapting to an environment that is in a constant state of flux? The extinction events during Pangea's time challenge the idea that life progresses toward greater complexity or diversity. Instead, these extinctions highlight the fragility of existence on Earth. The fate of the species that perished in these cataclysmic events serves as a reminder of the impermanence of life. What does this tell us about our own future? Are we headed for a similar fate, or have we learned how to adapt to the ever-changing conditions of our planet? While these extinction events marked the end of certain life forms, they also paved the way for the rise of new species. The aftermath of Pangea's breakup led to dramatic changes in the planet's biological history. Let's now explore how the separation of the supercontinent spurred the evolution of modern species. The breakup of Pangea did more than just reshape the Earth's surface. It set the stage for one of the most profound biological revolutions in the history of life on our planet. With the supercontinent splitting apart, what happened to life on Earth? How did these changes lead to the diverse ecosystems and species that exist today? As Pangea fractured, the land masses that had been joined together for millions of years began to drift apart. This geographical isolation created opportunities for evolution to take new paths. As species were separated by oceans and vast distances, they faced different environmental conditions and pressures. Over time, this led to the development of distinct species in each isolated region. The breakup of Pangea created natural barriers, forcing life to adapt to new climates and ecosystems. Some species evolved in response to the warmer, more humid conditions, while others adapted to the cooler and more arid regions that emerged as the continents drifted apart. One of the most significant impacts of this separation was the evolution of mammals. Early mammals had been small, nocturnal creatures that lived in the shadow of the dinosaurs. But as the continents split, the environment became more diverse, allowing mammals to thrive and diversify. This new freedom gave rise to the rich variety of species we see today, from the majestic whales in the oceans to the diverse range of mammals on land. The isolation of landmasses also led to the formation of unique ecosystems, such as the rainforests of South America or the savannas of Africa, each of which would become home to its own set of species. The evolution of life after Pangea challenges our traditional view of evolution as a simple, linear progression. Rather than steadily advancing in complexity, evolution is a tangled web of survival, competition, and adaptation to ever-changing environments. The fragmentation of Pangea accelerated the speed and direction of evolutionary change, leading to the remarkable biodiversity we have today. But this raises a fascinating question. What would have happened if the continents had stayed together? Could evolution have taken a different course if species remained interconnected across a single landmass? How much more diverse could life have been if these barriers had not been formed? The world we live in now, a fragmented collection of continents separated by vast oceans, is the direct result of Pangea's demise. But what if Earth's continents were to come back together in the future? Could history repeat itself, leading to another supercontinent? Let's explore the possibility of this geological cycle in our next segment. Since the breakup of Pangea, Earth's continents have been drifting apart, separated by vast oceans. But what if the process could reverse itself? Could the continents eventually come back together, forming a new supercontinent? And what would that mean for the future of life on Earth? These questions, though speculative, offer fascinating insights into the Earth's geological future and the potential for new patterns of life. Geologists predict that the movement of tectonic plates will eventually lead to the formation of a new supercontinent, sometimes referred to as amasia. This process is gradual and will take tens of millions of years, but the idea is that the current continents, separated by oceans, will eventually converge once again. The forces driving this are the same tectonic processes that caused the breakup of Pangea: continental drift, the shifting of Earth's crust, and the movement of tectonic plates. If this new supercontinent were to form, it would likely reshape the Earth in ways we can only begin to imagine. With the continents coming together, vast new mountain ranges could rise, and new oceanic patterns would emerge. The climates would shift dramatically, with some areas experiencing extreme temperatures, while others could become more temperate or tropical, depending on their location. The formation of this new supercontinent would have profound implications for life on Earth. Just as the breakup of Pangea led to the isolation of species and the creation of new ecosystems, a reunited supercontinent could cause ecosystems to shift, forcing species to adapt to new environments. In some cases, this might promote biodiversity, but in others, it could result in the extinction of species unable to adapt to the rapidly changing conditions. If a new supercontinent forms, it will likely result in the creation of new geographical features. New mountain ranges could change weather patterns and influence climate systems in unforeseen ways. The shift in ocean currents could alter the planet's weather and bring about climate extremes. For life on Earth, the formation of a new supercontinent could either support or devastate existing species, depending on how they adapt to the changes. The formation of amasia could lead to new biological innovations, just as the breakup of Pangea did. However, it could also create a period of great upheaval for ecosystems, forcing life to once again evolve in response to new challenges. Humanity, too, would need to adapt to this dramatic reshaping of the Earth. What lessons can we learn from the breakup of Pangea and the survival of life in such extreme circumstances? How might we prepare for a future where our planet's surface is again dramatically transformed? The future of Earth may be uncertain, but our connection to its past is clear. As we look to what lies ahead, it's essential to remember how the past, particularly the legacy of Pangea, has shaped the world we know today. Let's take a moment to reflect on the enduring impact of Pangea as we move forward in understanding Earth's evolutionary story. As we look around at the world we inhabit today, it's hard to escape the realization that much of what we see, from the land beneath our feet to the life that flourishes on it, has its roots in the distant past. How much of what we know can be attributed to the legacy of Pangea? The supercontinent may no longer exist, but its impact is still felt across the Earth. From the way continents are arranged to the species that populate them, Pangea's legacy is woven into the fabric of modern Earth, shaping not only our geography, but also the biological and ecological rhythms that govern life. Pangea's existence set the stage for the Earth we know today. The distribution of species across continents, for instance, can be traced back to the time when all the landmasses were connected. The formation and breakup of Pangea allowed species to evolve in isolation, leading to the biodiversity we see in different regions today. The landmasses themselves, formed through tectonic shifts and collisions, still bear the scars of Pangea's influence. Mountain ranges, ocean basins, and even the shape of the continents are all remnants of the supercontinent's existence. Even the very composition of our atmosphere, shaped by volcanic activity and tectonic movements, can be traced to the times when Pangea was whole. The process of continental drift that began with Pangea continues today, influencing climate patterns, ocean currents, and weather systems around the world. Pangea's influence goes beyond just the physical changes it wrought on the planet. It serves as a reminder of the interconnectedness of all things on Earth. The processes that shape the supercontinent's rise and fall set the stage for the interactions between land, sea, and air that continue to shape the environment. Life itself, too, is interconnected. Species that evolved in isolation, as the continents drifted apart, were influenced by the climate, geography, and ecosystems formed by Pangea's breakup. Reflecting on Pangea forces us to confront the fragility and interconnectedness of life on Earth. The supercontinent's formation and eventual breakup remind us that nothing in nature is permanent. Earth's past, present, and future are bound together in an eternal cycle of creation, destruction, and transformation. The gradual processes of continental drift and the evolution of life are powerful forces that operate over vast stretches of time, far beyond the scope of human experience. As we reflect on Pangea's legacy, we must consider what lessons we can learn from it. What does it tell us about the nature of change, and how can we apply those lessons to our own existence? What might we learn by contemplating the grand, slow movements of geological time and their far-reaching effects on life? Pangea's story is a tale of both destruction and creation, of change and continuity. It's a reminder that nothing stays the same forever, but also that life finds a way to adapt and thrive. As we think about the future of Earth, let's end with a thought-provoking idea. What would it mean to witness the rebirth of a supercontinent in our own lifetime? Could history repeat itself? And what would that mean for life on Earth? Let's explore this concept further in the next segment. Pangea, the great supercontinent that once unified the Earth's landmasses, has long since broken apart. But as we look at the fragments of that ancient world scattered across the globe, a crucial question lingers. Is the end of Pangea the conclusion of an era, or is it simply the beginning of another? The breakup of this once unified landmass may have marked the end of a chapter, but the question remains, did it signal a finality, or did it set the stage for something new, something equally profound? The cycle of supercontinents, with Pangea as one pivotal chapter, shows us that Earth is never truly static. The very nature of our planet is defined by change. Continents drift, collide, break apart, and reassemble in a slow but inevitable dance. This constant movement promises profound changes, but change does not always equate to an end. In fact, the story of Pangea offers us a powerful lesson. Destruction can often be the precursor to rebirth. Just as Pangea's breakup created new landforms, oceans, and ecosystems, it also provided the conditions for the evolution of new species, new ways of life, and new opportunities for adaptation. The breakup of Pangea wasn't just an end. It was a necessary precursor to the biological diversity and environmental richness we experience today. The cycle of Earth's supercontinents reminds us that, although the processes may seem destructive, they can be the beginning of something far greater. This question of whether we are witnessing the end or the beginning invites us to reflect on our own lives in relation to the grand history of Earth. Are we standing at the threshold of something monumental? Or are we simply part of a continuous, unbroken chain of events? If the Earth's natural processes can continually transform and renew itself, how can we apply this lesson to our own existence? How do we navigate the transitions in our own lives, whether personal, social, or environmental? The Earth teaches us that even in the face of destruction, renewal is possible. Each phase of life, no matter how challenging, carries the seeds of new beginnings. And perhaps the true lesson of Pangea is not that it was the end of an era, but that it was a powerful chapter in a much larger story. Take a moment to reflect on the grand dance of time, the rise and fall of continents, the ebb and flow of life, and the ever-changing Earth beneath our feet. The story of Pangea is not just the past. It is a timeless reminder of the impermanence and resilience of our world. As we look to the future, we can take comfort in the fact that, like the Earth itself, we too are part of a continuous cycle of change, rebirth, and growth. Just as the landmasses once came together and split apart, so too will the future unfold in unexpected and transformative ways. The question remains, is it the end of an era or merely the beginning of another? The answer perhaps lies in the very process of change itself.